Right, in this video, so I'm going to discuss about molecularity and order. So, what is meant by molecularity, as well as what is order, as well as the differences between molecularity and order. Okay, right. So, first let us see what is molecularity. It's nothing but total number of reactant species, total number of reactant species which take part in elementary step of a chemical reaction. So that molecularity is nothing but number of molecules which take part in a chemical reaction. Simple definition, molecularity is defined as the total number of molecules take part in a chemical reaction. Okay, so let us see one example. You have a reaction H2, hydrogen gas reacts with chlorine gas, giving 2 moles of hydrogen chloride gas. Okay, here we have 2 molecules. The number of molecules here is about 2. Hydrogen 1 molecule, chlorine another molecule. Totally there are 2 molecules of reactants are taking part in this reaction, isn't it? Therefore, the molecularity of the above reaction is about 2. Okay, so that is the definition of molecularity, total number of reactant species which take part in a elementary step of a chemical reaction. Okay, right. The next one is order. So order is defined as sum of powers of concentration terms in a experimentally determined rate law. That is, in an experimentally determined rate law equation, if you add the powers of the concentration terms, what you get is what we call it as order. Okay, so sum of powers of concentration terms involved in an experimentally determined rate law equation. Okay, so I have written one general reaction, X moles A and Y moles B reacting and giving products. Certain number of products are formed from X moles of A and Y moles of B. Okay, right. So the rate law for the above reaction is rate equal to rate constant K into concentration of reactants. Here reactants are A and B. So concentration of A and concentration of B, whereas the number of moles X and Y are written as a power of concentration terms. So that rate equal to K into concentration of A power X, concentration of B power Y. Okay, so this is nothing but rate law. Whereas here this X and Y are the power of concentration terms, isn't it? But now when we add this to X and Y, that gives the order, because according to the definition, order is nothing but sum of powers of concentration terms. Okay, so sum of X and Y is nothing but order of the reaction. Okay, right. So that is a general example. So I have given one specific example. Okay, so look at the reaction. Nitrogen monoxide NO 2 moles reacts with oxygen, about 1 mole, you are getting 2 moles of nitrogen dioxide. This is nothing but formation of nitrogen dioxide from nitrogen monoxide and oxygen, isn't it? Now the rate law for the reaction is written as rate equal to rate constant K into the first reactant NO concentration power 2. This 2 is written as the power of NO concentration. Similarly, oxygen, no number, it is understood 1 mole. Therefore, concentration of oxygen power 1, isn't it? But now which are the powers of concentration terms? This 1 and this 2. But now when we add them, 2 and 1, so you get 3, isn't it? So that is nothing but order of the above reaction. Okay, so order of above reaction is about 3. Okay, right. So this is about the molecularity and order. Okay, right. Now we are going to discuss the differences between molecularity and order. Okay, right. So order, first point is nothing but the definition, sum of powers of concentration terms. Order is nothing but what? Sum of powers of concentration terms in a rate law, isn't it? Which is nothing but definition what we discussed earlier. Molecularity, even here also first point is definition of molecularity, total number of reactants involved in a reaction. Okay, right. So very simple. Distinguish between order and molecularity. Sum of powers of concentration terms order, number of molecules involved in a reaction is molecularity. Okay, right. Then second one, it can be 0. Order can be 0. So we have 0 order reaction. Order can be 0, can be a fractional number, even an integer. It can be even an integer. It can be 0 or fractional or integer. order. But molecularity, it is always a whole number. Molecularity is always a whole number. It never be zero. It cannot be zero. Zero molecules, which means nothing, isn't it? But you cannot have zero molecules in any chemical reaction. So that it will be always a whole number as well as whole number, and it cannot be either zero or fractional number. Okay, right. Then order is assigned for overall reaction. Order is assigned for overall reaction. Suppose if you have a multi-step process, for the whole reaction you can give only one order, that's all. For the whole reaction only one order can be given, isn't it? But order is assigned for overall reaction. Only one order is available for a particular reaction. But molecularity, it is assigned for each elementary step of the mechanism. Suppose if you have a reaction which occurs in multi-steps, for every step we are able to give molecularity. So that for the same reaction, for every elementary step of the reaction, we are able to give a molecularity, isn't it? Molecularity can be given for each elementary step, but order can be given for overall reaction only. Okay, that's the third difference. Then fourth one, order is an experimental quantity. Order is an experimental quantity. By doing experiments only, we can find out the order of reaction, whether reaction is zero order, first order or second order, whatever it is. Okay, only by performing experiments order can be determined. Okay, whereas molecularity is a theoretical value. So once you know the stoichiometry equation, what is it? Stoichiometric equation. If you know the balanced equation of a chemical reaction, you are able to find out molecularity, so that from the equation we are able to find molecularity, isn't it? So that it is a theoretical value. But just from stoichiometry equation you cannot find order. It is done only by experiment. So it is an experimental quantity. Okay, right. Then the last difference, order depends upon pressure, temperature and concentration. So order can change with respect to the factors such as pressure, temperature, concentration. Even we have pseudo first order reaction also. There pseudo first order reaction, by changing concentration of one substance, we are able to reduce the order. A higher order can be reduced into lower order by using excess concentration of one of the reactant, isn't it? So that the order can be influenced by concentration. Likewise, even pressure and temperature also affect the order, isn't it? So it depends on pressure, temperature and concentration. Whereas molecularity, it does not depend those three factors: pressure, temperature and concentration. Okay, so these are some differences between order and molecularity. Sum of powers of concentration terms, total number of reactants in a reaction can be zero, fractional, integer, order. But molecularity, always whole number, cannot be zero and fractional number. It is order assigned for overall reaction, molecularity for each and every elementary step of reaction. Order experimental quantity, molecularity theoretical. Experimental na only by doing experiment, by using different concentration of reactants, only we are able to find out order. But molecularity theoretical value, which means just from the stoichiometry equation we are able to find out molecularity. Okay, right. Then order depends upon some external factors such as pressure, temperature, concentration, but molecularity does not depend on those three factors, does not depend on pressure, temperature and concentration. Okay, right. Thank you.